In the name of Allah, the most gracious, the most merciful. I am Engineer Hani Kamil, and in previous video we talked about transformer external fault and how our transformer is protected and the protection relay isolates the transformer if the downstream protection didn't operate, and even also if the fault was in the protection area of the transformer, so how also transformer is isolated. And now we are going to talk about transformer internal fault, meaning it's inside the tank, inside the winding. So we'll start with turn to turn fault and turn to ground fault in low voltage side and high voltage. We have transformer 132 over 13.8 kV and connected from 132 kV bus to 13.8 kV bus, and this transformer vector loop is dyn1. I add the facility to make the neutral point of low voltage side with solid ground or with NER or floating. We have CT1 and current transformer in high voltage side and CT2 in low voltage side, so it will provide CT1 and CT2 will provide differential protection. CT1 also will provide alone the overcurrent and earth fault protection. CT2 will provide overcurrent protection, and CT3 with CT2 will provide restrict earth fault protection. CT3 will provide sensitive earth fault protection. To make internal fault, I select, we have our 3 winding. I select R phase and I divided it to 10 sections. Each 10 sections, each section will have 10% from the transformer or the phase winding in low voltage side and high voltage side. And for example, if I closed switch X1 and switch X0, this will provide the first section or the first 10% from the winding to ground fault. If I closed X2 and X0, this will make fault in 20% of the winding. If I closed X1 and X2, this will provide 10% of the winding turn to turn fault. So let's start. I will make run. Now my transformer at no load condition. If I add loaded, if I add load, my transformer is working and loaded by around 65% and working in a stable condition. Now I will start to make a fault, but I will remove the load so we can see only the short circuit current. Now I will start with isolating system, means the neutral point is not grounded. For example, I will make full winding, means face to ground fault in the full winding, because transformer neutral point is isolated and now are phase to ground fault, so there is no current, short circuit current, only the R phase voltage is 0 and neutral current is 0 because the system is isolated, so protection cannot work. That's why in isolated system we use the exact transformer. It will help to find a path for short circuit current, so it will help the protection relays. Now I will start with neutral point, solid ground. I will make first 10% from the winding to ground fault. We see the protection already worked and it gives trip command. We can see which protection operated. This is a disturbance recorder. We can see the restricted earth fault operated. This is our fault. So when we make the fault and the restricted earth fault operated, if I make continue and if I make force reset, so this is a short circuit current for the first 10% of the winding because it's low impedance or low reactance. That's why the short circuit current is high. Due to high transformation ratio between high voltage winding and low voltage shorted winding or shorted percentage winding, so the current in low and high voltage side is little less, so still less than the 38% from the winding rated current, so over current cannot work, and depend on the protection relay setting. So we can see first restricted, then differential, then reverse fault. Now I will clear the fault, upset. Now system again working. If I fail, I make turn to turn fault in the second section of my transformer. Okay. I have to remove the earth fault. Now I will make turn to turn fault, and I can see system protection operated and it gives trip command. I can see which trip happened. Yes, our last fault is differential protection. If I make force reset, so because the current is high in high voltage side than the differential minimum current, so differential operated, but because this turn to turn fault, so there is no neutral current, so reverse fault will not operate. Also because there is no the fault is internal, and so the current will not be in phases, means the phase T of the low voltage side. So also the restricted RC fault or overcurrent in low voltage side will not operate. This is our case for solid ground. Now I will make a neutral point will be with NER, and I will start with turn to turn fault. So again, protection operated. We can see which protection function started or operated. We can see differential operated. I make force reset. So again, only differential will operate. Restrictors fault will not operate. Current is not available in neutral or phases. Also, Snesver's fault will not operate because there is no current in neutral. Now I will start to make turn to ground fault or earth fault. So I will make in first 10% from the winding. The neutral point resistor or earthing resistor is 10 ohm. So now it's limiting the current is around 80 ampere. 80 ampere is in my case it's less than the setting for infinite earth fault and restricted earth fault. Also the current in high voltage side is small, so it will not give any protection. I remove the reset and see the system is working and protection didn't operate. I will start to make second 10% mean 20% from the winding is shorted with ground. Still no operation. 30% from the winding shorted to ground. Still no operation. 40%. Still no operation. Because this all because of neutral earth resistor is limiting the current. So protection is the current now less than the setting. First 50%. Or till now 50% from the winding is not protected. And first 60%. Still not protected. And 70% and operated. You can see it gives trip command and transformer now isolated. You can see which trip function. It's restricted earth fault. We can make force reset. So only the restricted earth fault. The current is more than the setting. Differential current is small for differential protection. So differential will not operate, and also this maybe over current sensors fault can operate, depend on the setting also. you can see the differential, the resistor is fault operated, then the sinus reverse fault operated for low voltage side. Now by this setting or by this NER value and the old setting, so around 60% from the winding is not protected. Solution for this, will adjust the setting to enable the restricted earth fault to protect even the first 10% from the winding. For example, if we make first 10%, it gives 80 amperes, so around 3% from the rated current of low voltage side. So we can adjust the restricted earth fault. For example, 0.2, and we'll make run. We will remove reset. Now I will make first 10% to ground fault and protection operated. You can see which protection started. You can see the restricted earth fault now can operate and protect the transformer. So if we're using NER, we have to adjust the setting to increase the sensitivity of the restricted earth fault, also sensitive earth fault to protect transformer, even so we'll keep all the winding protected. Now I will shift the fault from low voltage winding to high voltage winding. So now if I close X1 and X0, the first 10% from the high voltage winding will be shorted to ground. I will update here to make the measurement in 132 side for short circuit current. Now I will start with solid ground. Actually, in high voltage fault, solid ground or NER will not affect. Now I will start with the first 10% from the winding, each high voltage winding to ground fault. You can see the protection operated and trip the transformer with force reset. The current in blue phase, because this one is connected between H1 and H3 for R and blue, so the current in blue phase is very high, also in R phase. So differential is expected to operate. Here also overcurrent expected to operate and earth fault for high voltage winding expected to operate. You can see which protection operated. So first differential, then sensitive earth fault, earth fault, then overcurrent, phase overcurrent. I will clear the fault. Now I will make the 60% of the winding, so it is the lowest point in voltage in the winding, but delta, so the center point almost have the lowest stress. We'll see if transformer is still protected or no. Yes, it's protected. So I'll make force reset. And same we expect differential sensitive fault and phase overcurrent. Same available. Differential, then sensitive, then earth fault, then phase overcurrent. If I make turn to turn fault, differential protection operated, and we'll see by force reset. Now we expect only current is less than the setting of the overcurrent, so overcurrent will not operate. The fault is not with ground, so the fault current, the earth fault will not operate, but only we can see the differential will operate. So we can see only differential is operated. At the end, thank you for watching my video. I am Engineer Hani Kamil. This is my contact as shown. Any suggestion or discussion, you're welcome. You can contact me directly. Don't forget to subscribe my channel to get notification for coming video.